Hi everybody, my name is Joey and I'm the Perfect Score Tutor. I've gotten perfect scores on both the SAT and ACT. However, I'm here today with a copy of the 2024 free response questions to the Calculus AB exam. I'll be breaking down the free response questions into detail so you can predict how you did on this exam. Or if you're looking at this from a future test date, you can use this walkthrough to study for your upcoming calc exam. Question 4 says the graph of the differentiable function f shown in the figure has a horizontal tangent at x is equal to -2. Let me draw that in. And is linear for 0 to 7, so that's a straight line. Let R be the region in the second quadrant bounded by f. The vertical line is -6, and the axes, region R has an area of 12. The function g is defined as the integral of f from 0 to x. So let's find the values of g of -6, g of 4, and g of 6. So let's do g of -6 first. So g of -6, I would just plug in -6 into my bounds. And when I do that, I don't like having the smaller number on top, so I'm going to rewrite this by negating it and then switching the bounds like this. So basically, the integral from -6 to 0 is asking me for the area under the curve. Well, the area under the curve they give us is positive 12, but I already took a step and made a negative in my head. So this is the first one. Now for g of 4, I'm going to do the same thing. So g of 4 is just going to be the integral from 0 to 4. This one I don't need to flip around because the smaller number is on bottom and the bigger number is on top. I want the area from 0 to 4. This is just a nice little triangle. It says that this graph is linear, so then this is just going to equal 1/2 times the base times the height. So then g of 4 is equal to 4. And then finally for g of 6, I'm going to rewrite this because I like to showcase my work. So then I want to take the whole area from here to here. This is another triangle, but because it's below the x-axis, I'm going to need to subtract that area. So it's going to be this 4 from this part, and then it's going to be minus 1/2 times 2 times 1. So then this is going to equal 4 minus 1. So then g of 6 is equal to 3. Part B says for the function g defined in part A, find all values of x at which the graph of g has a critical point. So remember, to find a critical point, we want to take our derivative and set it equal to 0 and also find where our derivative is undefined. So let's find g prime of x. Well, this is the fundamental theorem of calculus in that if we take the derivative of the left side, we want to take the derivative of the right side, and the derivative of an integral is just that function itself. And now we're going to set f of x equal to 0. Where does f of x equal 0? F of x equals 0 when x is equal to 4. It says give a reason for your answer. G of x has a critical value at x equals 4 because g prime of 4 equals f of 4 equals 0. I don't think you need to give any more of an explanation than that. Part C now gives you the function h, which is defined as the integral of the derivative of f from -6 to x. Find the values of h of 6, h prime of 6, and h double prime of 6. Let's show the work. Okay, so h of 6 should be fairly straightforward in that we're just going to plug in the numbers into the bounds, right? So it's the integral from -6 to 6 of f prime of t dt. Now, the tricky part here is that we're given the graph of f, so we can't find the area under the curve. So instead, we're going to need to use the fundamental theorem of calculus. If we're taking the integral from -6 to 6 of f prime of x, that's going to equal regular f of 6 minus regular f of -6, FTOC. What is regular f of 6? F of 6 is -1. That's the point right there. And then what is f of -6? It's equal to 0.5. So then h of 6 is equal to -1.5. The second part, h prime of 6. H prime of 6, let's find h prime of x first before we do h prime of 6. So h prime of x, like we said in part A, right, if we took the derivative of an integral, it just replaces it. So h prime of x is equal to f prime of x. So then what is h prime of 6? That's going to equal f prime of 6, and f prime of 6 is the slope of this graph at 6. So what is my slope doing? I'm going down 3 over 6. So we can just say it's -1/2, or if you want to take the extra step and show the work that you're doing, you could just write is equal to -1 minus 2 over 6 minus 0 is equal to -3 over 6. Right? It's better to show work than to just plop a number without showing that work. Finally, we want h double prime of 6, so we want h double prime of x, which is just going to equal the second derivative of f. And then when we plug in 6, that means we want the concavity of the graph of f at 6. Well, a straight line has no concavity, so then our h double prime of 6 is equal to 0. How can you show the work? I don't know. You just got to say there's no concavity at that graph if you just want to showcase that. This one is an interesting question to figure out how to distribute points for, because I think it would make sense that part A would be worth 3 points, right? And part C would be worth 3 points. So I'm trying to figure out why part B would be actually worth 3 points, right? You would get a point here for setting that g prime of x is equal to f of x, and then you'd get a point for your explanation. Where else would we get a ninth point then? I think maybe you can get a ninth point here by showing that you understand the fundamental theorem of calculus over here. Or maybe you get a ninth point here by understanding that a second derivative of a line has no concavity. I think part C is where you'd get your extra ninth point on this question. Thanks so much for watching this video. If something was unclear or you need me to break down an explanation even more, feel free to leave a question or comment below.